My presentation has the content of.
Just define what you mean by attribution.
Attribution is basically a kind of identifying a cause actually, when you actually look at. For example, when we say attribution, we're trying to look at whether climate change is a cause for happening of any kind of event, any extreme event. My focus is on extreme event. I'll first start with global temperature and a pattern of global temperature. If you look at the first graph on the top, it seems it's a 100-year data which is actually arranged. What we look at is there is a clear trend in temperature pattern actually. Interestingly, if you go to the second graph on the bottom, if you look at last 10 years and how last 10 events, which are the warmer event, which has a higher anomaly with respect to the average period of 1850 to 2015. Last 10 events were the event of the recent period actually. If you look at most of the events are up to 2000 actually. And more interestingly, the year 2015 was the warmest year in the global history actually, historical period. And the anomaly was 0.9 degree actually, which is quite significant. So this sets this is what is already been discussed already, that the temperature is warming and it's warming at a faster rate actually. If you look at the trend in first 50 year and second 50 year, what we can find is the recent 50 year has a higher trend actually. So what is an impact actually? I've taken this figure from NOAA website to look at what has happened in the year 2015 in terms of extremes actually. If you look at, because of the warming of 2015 actually, what we can look at, most of the region across globe has heat wave activities. Yes, there are cyclonic activities, particularly in US area. A lot of flood has actually occurred. China was suffering from flood last year. India heat wave was very serious last year, as well as flood in the northern areas. So these were some kind of events which are actually triggering. So the next figure, I've taken the data from EMDAT website to take the kind of amount of mortalities due to climatological event. I've focused on the climatological event. It's a countrywide data. So what we can look at, France and India, in terms of mortality due to climatic events is very high actually. It's probably because India was suffering from heat wave and more than 2,000 deaths has been reported in India. Similarly, France was also suffering from heat wave actually, and higher death was reported in France. So the normal question when these events, the question comes in that normally floats in media among the experts is whether climate change is responsible for these events or not. Generally, if we generally discuss with experts normally say, and some experts normally say that variability is responsible because such kind of events were happening in the past also. So, but recently, in the last 10-15 years, there has been some advancement in terms of developing attribution studies. I would just go to one study of done by Miles Allen and Scott, which was published in the year 2004, which was an outcome of a heat wave in Europe. So the idea is to understand what causes heat wave, and then they did, in that sense, they actually developed the methodological background of attribution in that subject. And that has actually set a basic idea of what do we mean by attribution and how to attribute, suppose someone wants to attribute to climate change, in what way it can be attributed. So what is the need for the attribution? So as I said, there is a kind of discussion what causes climate change, whether the event has been caused by climate change or not. So attribution helps in that sense. Attribution is also because if events can be attributed to climate change, it helps to the planner, it helps to the emergency manager in order to understand, because it is happening because of the climate change. So there is a possibility it will happen again because there is a clear signal in the climate. So it also, if you look at Warsaw International Mechanism, which has been discussed yesterday also, attribution, loss and damages is one important part, but at the same time, compensation and liabilities are also a kind of discussion which is going on. So attribution is an exercise which can help us, which can help in terms of setting up compensation and liabilities also. So what we mean by attribution is, as we discussed, identifying the cause. So here the interest is climate change, whether the change in a global warming is the cause for occurrence of extreme, whether it is flood extreme, cyclone extreme, heat wave extreme, and other thing extreme. I just go to the next slide. So what we need, suppose we want to attribute any event to climate change. So what we need, I'm just quoting what IPCC has indicated is observation records are very important. If we have observation record, these are the first important criteria. Then model, because models are the way we can simulate climate conditions actually. So we need a different model experiment. In generally for attribution exercise, model experiment with climate change scenarios and model exercise without climate change scenarios are required actually. What we call in attribution, what attribution studies refer it to a counterfactuals actually. In that model exercise, the important element or component is internal variability. So the model experiment with climate change and model experiment that simply simulate internal variability. So these two are important factors, as well as the other thing like experiment with natural forcing, experiment with other volcanic forcing and other forcing also, so that we can identify an event, whether the event was falling in natural forcing or internal variability in a climate system or greenhouse gas forcing. The problem with the attribution is because natural forcing is clubbed with the climate change component. So there are, because natural forcing in other words is a noise to a signal, and climate change component is a signal actually, a trend basically. So it's a mix up of a trend and noise actually. So the basic approach for our attribution exercise is to separate trend and separate noise actually, which is very important in any climatic data. So what global studies has done so far, they have actually focused on what studies has been done so far. They have focused either on a global attribution or a regional based attribution, and studies has found there are clear signals, particularly when they take a large region, take a large group or selected region, selected group. They found signal that climate change can be responsible, can be actually, or global warming can be responsible for occurrence of extreme in the region. I'm just quoting a study of Wen et al. 2013 in China. They found that in temperature extremes, the global warming is a responsible factor. 2011, Min has also put up a paper where they actually selected a specific region of North India and found that extreme temperature in North Hemisphere, and they found extreme temperature in Northern Hemisphere occurrence of extreme climate change is a responsible factor for that. Now, we also did to look at this study to look at how can temperature extreme in India be related to, climate change can be attributed to a temperature extreme in India. For that purpose, we have taken 24 runs of greenhouse gas forcing, which is basically the forcing that includes the element of climate change. 24 runs of climate variability also, which is basically a variability. There is no component of climate change. There is no signal component in it. Simple variability. If you simply look at variability, whether events falls in a variability or not. And 34 forcing of natural variability. Some natural factors that model considers, and it has run with those natural factors. So the panel A is basically the observed data of the period 1950 to 2013. And what we are looking at a trend in the observed data, and dots in the trend specifies the trends are significant, statistically significant, and 95 percentile confidence range. Panel B is for the internal variability, and we're trying to look at whether this trend is, can we see the trend in the internal variability or not. What we found that there are very few models, even less than 20% of the 24 model that we have selected, that shows some trend actually, but most of the model does not show trend. Panel C is the greenhouse gas forcing, the models with climate change component in it, and what we found, majority of models in this are showing trend, and these trends are very much matching with the dots actually. So dot is basically a reference that observed data has a trend actually. Same is the situation of panel D, which is basically natural forcing. The situation is same as panel B actually. So again, in natural forcing there is no kind of observation in terms of finding trend in the data. So we then, to discuss more, we actually look at optimal fingerprinting exercise. Optimal fingerprinting exercise is basically identifying a fingerprint in a particular forcing of run action. So it's just like a regression exercise where independent data are model simulated data and dependent data is observed data actually. And the residuals of the regression are considered as the climate variability. So the data from a climate variability is considered as a residual actually. What is unknown in this particular framework of setup is basically the regression coefficient. So what we try to look at, what is the regression coefficient, and if the regression coefficient is close to 1, it means a particular forcing can be attributed to data basically. The data signal is there in the particular forcing actually. The panel on the bottom is actually the graph that shows that weather model are actually simulating climate variability similar to the observed data variability. If it is within the band, which is 95 percentile band, it means that the model data are simulating climate variability better actually. Panel on the left side is greenhouse gas forcing, and panel on the right side is basically natural forcing actually. And the EOF means is basically what we try to do is improve the signal strength in the data. So the higher is the EOF, the larger is the EOF. First order, higher order EOF always improve the signal ratio actually. Because if the signal ratio is improved, we can find out the signature of event basically. That is what we call fingerprint of the event basically. So what we found that scaling factor for first few EOF are, in case of if you look at the panel A. In panel A, the scaling factor is very much close to 1. Even in the 95 percentiles, the band, our first few EOF are within the 1 actually. So it is different than 0, and 1 is there actually. It means that we can attribute because it is 1-to-1 relation, and if it is between 0, falling between 0 and minus, it has a minus and plus basically. It means that the results are inconclusive. So if it is more than 0, the results are conclusive, at least the direction is same actually. So this is one way of identifying that the temperature, this is what we looked at, the temperature is attributed to, the extreme temperature is attributed to climate change in India. Basically the point is, the issue is that what we have so far looked at and what the study has so far looked at is basically the attribution of regional temperature. Now the major discussion is whether a particular event can be attributed to climate change. Because individual events are very location specific, are subjected to higher variability in a climate component. So it might not be related to climate change basically. So there has been a lot of gap. As I said, the first study which was published in the year 2004, and then the next study was 2010 onwards. So there has been gap from 2004 to 2010 actually. I'm just showing the graph of from the Trenberth et al. What it has indicated that wherever there is a change in sea surface temperature, there is a kind of occurrence of extreme in the adjacent location. So it has been become a kind of hint to the people who are working on event attribution that sea surface temperature can be one of the important driver, as well as the other large scale forcing can be important driver. So what they did is basically they run their model with large scale forcing and sea surface temperature, and then try to look at whether the variability component can be identified in this run or not. So I'm just presenting a study of Pal et al., which is basically one kind of milestone in terms of identifying event attribution. So what they did, and before that I just go to a background of this, because such studies needs a very large simulation of climate models, and the current computation capacity, whatever we have, doesn't make it possible to have such large simulation. So this is actually a project which was done by Oxford University in collaboration of BBC, what is known as climateprediction.net. Whether they started this project, is known as Weather at Home actually. So it is basically a kind of distributional computation exercise where individual can donate their RAM memory and they can run the part of the code in RAM memory and take the code back to their distribution servers actually. because of this, they could actually locate memory, and they can do the exercise in number of computers. They have done number of simulations, more than 10,000 simulations in this. And based on those 10,000 simulations, what they looked at is whether they can, they actually simulated 10,000 different kind of variability, natural variability, and also they run the model with 10,000 kind of the climate change component, actually, GHG forcing. The model run with the GHG forcing and model run with the natural variability. So the graph, in this graph, actually the blue color shows the model forcing with GHG, and this is particularly, they studied the inland flood actually, and they tried to look at whether 2000 flood in England can be attributed to climate change. And the different colors in all four panels show the internal variability, model with internal variability. There is no climate change component in the model run, only internal variability has been shown there. What they found is that the return period for a particular, the horizontal black line shows basically the precipitation amount and runoff amount for the period when England flood has actually occurred. And these four panels are four different models actually. So what they found is the return period is very lower in case of greenhouse gas forcing. It means that such events are occurring faster and faster, or there is a higher probability of occurrence of such event actually. So this is a first study that has actually set out, they focus on an inland region, very small region, and then simulated number of model runs, and then they identified, in other words, they actually represented all kind of variability which can occur in a climatic system, and then they look at whether a particular event can be identified, or is there any possibility of looking at this event in a natural variable. Just like putting a null hypothesis that climate change is responsible, and other thing is whether it is also responsible another thing or not, and nullifying that it is not responsible in another thing, it is responsible in, or can be found in that particular factor. So this is just the background of extreme event. I'll just set aside. So Indian context, what is the difficulties? One is as event-based attribution, and for example, suppose we would like to look at Uttarakhand flood or Chennai flood and other flood. One of the interesting thing is we need to have like what Pal et al. Have basically in terms of a large simulation of distributed model simulation that actually simulates number of runs for internal variability, which is slightly not available in condition. Also, observation data, particularly for Uttarakhand flood, I'm just quoting a study of Dipti et al. In BAMS. What they found is when they're trying to look at the attributed Uttarakhand flood to attribution, what they found is the data were not sufficient, because the particular flood, if you look at the data, whatever the data has, the particular flood was of the kind of return period, has a return period of 111 years, which is not available in Uttarakhand like setup. For example, suppose someone wants to study Mumbai-like event, which is very high actually. That particular event would be around 1:1000 year scale actually. So the data itself is not sufficient, whatever available. So that sets a major limitation in the Indian condition actually. In addition, some of the extremes has co-founding factors like drought. Basically drought because of the management practices, because of the way we actually take groundwater, all these factors are also responsible. So that actually sets one of the limitations. So in that sense, what is important is the definition of extremes. In what way we are defining extreme, it becomes an important, and it comes from the impact people, those who are actually working on impact side, they can tell us this is a value which is basically making an impact actually. Then probably it can go for attributions based studies. So I'm just summing up what the studies and are indicating actually. So what, if you look at currently what is the domain of attribution, so most of the attribution study, whether it is a global scale attribution study or event-based attribution studies, are focusing on developing countries, developed countries. Sorry. So developing countries, these studies are very, very limited and almost nil actually in the developing country scenario. What I'm just quoting a paper of Otto et al. Who worked in Africa trying to look at the attribution of extreme event. What she is suggesting is basically that definition of extremes are very crucial, and it has normally, it should come from a kind of dialogue between science and policy, because the first, the definition is low. It may be more number of events can be identified and can be related to trend and other. If we set a definition very high like Mumbai like event, there will be no event actually, or one event cannot be looked at in terms of attribution. Generation of multiple climate models with different climate experiment with climate variability, with climate change can be a very crucial in this case, as we have seen in Pradeep Pal et al. Paper actually. He used a number of multiple climate simulation in order to simulate variability actually. Also historical record as we discussed actually, which is a major limitation in most of the developing country scenario. India might be better in terms of having historical record in comparison to developing countries. Because we are right now, the remote sensing data is improving, so probably the use of remote sensing in future can be a very good factor which can give us a good time series of data, and other reliable data actually. So that's all from my end.